Yeah, those were the questions before the break. Can you ask them again? I did not get the questions that were in the chat. But we are almost finished. We're almost done with the presentation. I think there are just a few slides.
I have a question.
Yeah, we just have 3 slides. Yes, I'm listening.
Okay, if let's say if some samples were collected, right? And then they were good residuals. And when you read the results, then there are coliforms present. Would you say that these samples were contaminated while you were collecting it or when doing the analysis? Because you have good residual?
If the residual is good, in terms of what is stipulated for our distribution system, and we still get coliform, you can mean one of two things. Either the level of coliform growth in the water is extremely high, or there was some kind of contamination in either taking the sample or in testing. So either one of these two things would be true. Either either coliform level in the water is very high, or contamination of samples.
I think this is well said. In an extreme case, some elements bacteria.
Aloysius, are you still talking? Alphonsus, sorry, are you still talking? Because we were not. Oh, you stopped. Okay, because I was not hearing you properly while you were speaking. So I'm not sure if you want to repeat.
Okay, you hear me now?
Yes, I'm hearing you clearly now.
Right. But I think the mic get pulled out a little. Now, I was saying that case that he raised, I would like to ask if specifically you're talking about a samples from raw water or treated water. The case of the issue of getting a good residual chlorine and at the same time still getting total coliforms and maybe fecal coliform colony is very high.
Treated water.
In treated water?
Yes, sir.
Yeah. I think most likely is a recontamination or something like that. You see, if it's in the raw water, then the discussion that Alvin started is very relevant. Because if it's an extreme case and you have pollution, what happens when you have other additives? Sometimes the bacteria, the colonies get shielded by other contaminants, so it doesn't allow to do what it wants to do. In some cases, there are some cases, and the most relevant to wastewater too. Some cases you dose, and you dose a high level, because you know you have all kind of stuff in there, and you could get when you finally look, you will have you could have what I call a residual that you think is reasonable, but could have gotten eaten up or scavenged by other stuff besides the targeted bacteria that you're looking to at. And as Melvin said, initially you don't test for all, you test for an indicator. The total and the fecal will tell you, well, there's very possible other stuff. And I just wanted to highlight too that when you go and you test for the Escherichia coli, I want us to remember that almost always the Escherichia coli belongs to the zoo. what I call a zoo, which is in the large intestine of mammals, so in humans and animals. So once you see you have Escherichia coli, you know what's happening there. Pollution, pollution, serious pollution. Okay.
Okay, great. Thank you so much. Very valid contributions. Okay, I'm going to go back to the thing. I think I have 2 more slides to go through, and then I'm going to hand over to Mr. Daniel. I think I closed my presentation, did I? That's it.
You share the screen and you're doing it now.
Yeah. Okay, so we were just about to look at copper and lead rule, or lead and copper rule. This is a rule given in the Safe Drinking Water Act. It requires first draw samples, and as I said earlier, it means that we are going to take the first set of water that comes out of that pipe. So we're not flushing the tap. We want the first set of water that comes out of that pipe after the water has been sitting for 6 to 8 hours. I think I have that in the slide somewhere. Okay, but not more than 12 hours. So first draw samples. It is often collected by residents because most times we collect at points either in the kitchen or in the bathroom. Now, it's kind of the operator, the distribution water operator will most likely not go into somebody's house unless they're in the area and they're taking from their own house early in the morning before the individual consumers have started using their taps. Okay, that's not most likely not going to happen. So it is allowed for we have consumers who volunteer to collect samples. They are taught how to take a good sample. Okay, they may even be given the containers of bottles, the sample bottles with which to do so. Okay, so before anybody uses the tap, after the water is sat in the tap overnight, the individual will take a sample. Okay, so I said that already. It's taken in usually in the kitchen or the bathroom. I said that also 6 to 8 hours before sampling, but not more than 12. Okay, and samples must be analyzed by a certified laboratory. Now, with all of what we have mentioned, anytime we're doing analysis, the sample must be analyzed by a state certified, mind you, laboratory. We want to ensure that the people and the company and the equipment being used is up to standard and gives us results within a certain level of accuracy. So we don't want to, when we use a lab that is not certified, this means that the lab may be using procedures, equipment, etc., that is not up to the standard required for drinking water. So these labs that are state certified, we know for sure they went through a certification process, and we know that the methods and equipment that they will be using will be appropriate. We know that the staff who will be using the equipment and the methods will be certified as well. So we are sure that when results are given, we can rely on these results. Okay? So we're not going to do anything in a chock-a-block kind of manner where we just letting anybody do any test for us. Remember again that this water is something people will put in their bodies, and we have to maintain a certain standard because we into keeping people alive. Water is supposed to keep people alive and not kill them. So this is the lead and copper rule. Now we come to the last slide of this presentation, where I want to remind you that there's more to study on the CAWASA online platform in terms of these things, as well as I wanted to send you back to the Safe Drinking Water Act, so that, because there's stuff in the Safe Drinking Water Act, there are things that you need to remember. Okay, so you need to be looking at it not just in the week that we did it, but you should be looking at it over and over so that you could remember some of the rules that are there. Eventually, as operators, you will have to make use of this information. And the more you remember, the quicker you can make decisions when you're out in the field. You will not always have the opportunity to go check. What does the Safe Drinking Water Act say again? Okay, you may not always have the opportunity to check it. But if you are familiar with it, then you can act in a manner that is intelligent and that will maintain standards in whatever distribution system that you belong to or where you work. So that's it for the things that I wanted to go through. I want to remind you that I have added another presentation on common water quality problems, and I'm going to hand you over to Mr. Daniel, who is going to do his part. But before I do I have any questions? Sorry.
I think I've seen some in the chat. Check it out.
Do you have any questions? Because when I do full screen, sometimes I don't see the chat.
Yeah, I think I've seen one in the chat, Alvin. You hearing me? Hello?
Okay, somebody made a statement. That's Naib. I'm not sure if I'm pronouncing the name right. Naib is saying, to my knowledge here on island, when it comes to sampling, a number of different companies check behind each other. I'm assuming he's saying that several different companies check so that you have several different results. Is that what you are saying? Okay, I'm assuming that's what he's saying. He's a he, right? I'm assuming that's what he's saying. Okay, and that's often done so that you have what we call redundancy. So you have several different results. So if one place that's analyzing messes up, then the other place may show them up. Okay, because if everybody is doing what they're supposed to do and they don't mess up, then we should get similar results. But if we don't get similar results, it tells us something went wrong, and then we can go back and sample and test again, if that's what you're saying.
Yeah.
Okay. So I hand over there.
Indicating yes.
Okay, great. So I hand over. I'm still here. Okay, but I hand over to Mr. Daniel. You stop sharing. Now let me see.
Okay.
Now, Mr. Daniel, as you go, I will tell you when this thing is going to.
Yes, and I'll try and get you. I just want to spend some. Good morning to all again. We want to spend some time on some calculation. You know, the calculation is always part of it. It's always a challenging part. But that's the part that once you practice, you could master it. So what I'll do, I don't have a PowerPoint today, but I want to share my screen, whiteboard, and work some calculations. I trust everybody have writing implements, and also I want you to take some questions down because I'm going to call the questions. They're relatively short, and as you know, it's calculation that has to do with chlorine dosage, the amount of chlorine that you dose to treat, and so on. I want to take you from what I call the simplest form to a little more complicated. So I will try and go through 4 illustrative examples, and I don't want to leave anybody behind. So if you don't understand something, please indicate. I also, some of us work differently. I like to, and I think it's a good way based on my experiences. If you know where a formula coming from, although you don't remember it exactly as it should be, you could appreciate it more and know when to apply it. Now I will state, for example, the formulas that we're going to use. I'll put one in the simplest form, and I'll show you it's the same one that that is in the formula sheet. I will put it in that form. I'll just juggle it and play around with it. So basically we have 3 formulas that we're going to be playing with here that you pay attention. And as again, if you don't understand, please indicate stop. I could go over and so on. Okay, the first problem, I want us to take it down. I'm going to call it out and take it down. It's a one-line question. It says calculate the amount of chlorine required for a dosage of 100 milligrams per liter in a 525,000 gallon elevated storage tank. And that one is familiar, but I thought of starting off with that one to take you from the simple. So let's take it again. Let's make sure everybody have it. Calculate the amount of chlorine required for a dosage of 100 milligrams per liter in a 525,000 gallon elevated storage tank. Okay? So they're asking us to calculate the amount of chlorine. If they ask me about the amount of chlorine, the first thing that comes to mind is pounds of chlorine. And as usual, you may want to set up with it with what you know, known. And the unknown, as usual. The known and the unknown. For all chlorine. First thing. So the amount. And I'm saying then a question mark, and remember we're looking for pounds, LBS. What we know, they told us that the dosage and the dose, we know the dose is 100 milligrams per liter. What else we know? We also know a flow, well, not a flow, a volume in this case. The volume is 525,000 gallon. That's your storage tank. Now, a few things that will jump out from the beginning. Remember I said the other day that the true name for when you're doing mathematics, the true name is mathematical analysis. So you should read again and look to see what you know and start to analyze. And one of the first things I want to remind you of, remember it's accepted in our water treatment and so on, that 1 milligram per liter is the same as 1 ppm, 1 part per million. Remember that. Have that foremost, approximately equal. You accept it as equal. Have that foremost in your mind. A milligram per liter is the same as 1 ppm. Another thing that jump out to you when you're doing these questions with in terms of calculation dosage of chlorine, the formulas that is stipulated that we use And what they want us to remember, it is in million gallons a day. MG or the million gallons or MGD as a flow. MGD. Remember that. So if I see in a volume, here as equal to 525,000 gallons, I know my volume, I could change that one time to 520 gallons divided by a million. And what is a million in scientific notation? In scientific notation, 1 by 10 to the 6. All right, that's 1 and how much knots? And your calculator is still a bright piece of device you have there. You should have it handy. So that is 0.525 million gallons. I want us to remember that. So with that, now we set to work the question. If we have any doubts, ask me now. Because I'm going to start to rub off. You know, the screen is small. And trying to write with a stylus is not the best of all. But I think that's the way you better do it step by step and explain it. So everybody clear on that? All right? If I didn't see anything in the chat, Alvin, if you see anything in the chat, you please indicate to me.
Yeah, I'm right there.
All right. So if I didn't see anything, I will take it that we all clear. All right. I will take it that we all clear. So I need my space now. So I have my volume. I have my dose. I'm putting on a formula, and that's how I want you to remember it. And if you don't remember it by heart, it's easier in my view to remember it that way, the concept that way. And I will take it right into the form. It's the same formula. I take it right into the form as they have it in the formula sheets. So look at that. Let me do some erasing first. So I'll make some space. And everybody take that down. Remember, they're asking me for amount, they're looking for pounds. Always remember, in your water treatment, million gallons multiplied by 8.34 pounds per gallon. You know where that came from? That's the weight of a gallon of water. Multiplied by the dosage. And I'm going to put it down as milligrams a liter. Per liter is also ppm. I want you to remember that too. That will always give you how much pounds of chlorine you need. All right? And we're still there. If the question, they decide to swing the question and use ppm, have it in your head also. As I say, 1 milligram per liter is equal to 1 ppm. So I'm also saying to you that million gallons, not milligrams. The million gallons is the same formula by 8.34 pounds per gallon. That is water multiplied by ppm. still give you pounds. And in this case, pounds of chlorine. Watch it good. It's an equation. And I would stick in one time. And it makes sense to you, and I know you could handle that. They're not just talking about a volume, but in addition, they're talking about a volume per day. In other words, now a flow rate. Million gallons per day. Or MGD is equal to the same 8.4 pounds per gallon. You can change that as the weight of a gallon of water by the dosage, whether in milligrams per liter or ppm, would be pounds per day. It's the same thing. All right? So have it there. I'll go back to it and convert it just now, but let's work out the problem now. Let me clean up a little again. So here we go. We're walking back into this one. We're walking here because they wasn't talking about that day. They just give us a volume in an elevated storage tank. So MGD was 0.525 multiplied by by 8.34 multiplied by milligrams per liter. They say it was 100. And when you work with your dimensions, you will get pounds. So if you work that, remember here, you're paying this one, we're not talking about that flow, we're not talking about that day or 2 days or whatever. If you work that, if you have a calculator there, that should give you 43 nice pounds. That should give you 43.78 pounds. This would be the amount of chlorine that we need to add of 100 milligrams per liter in a tank of 0.525 million gallons. Everybody clear on that? Forward. Mine.
Yeah, somebody has a question, Shannon.
Yeah.
Wants to know whether all of these are to calculate the US gallons or otherwise.
Yeah, we're working in. Remember, I said it from the beginning. When I introduced the topic, more parts of the world, a gallon for all intents and purposes right now is a US gallon. As a matter of fact, apart from some of us who use it and so on,
you went silent there. I'm not sure what happened.
gallon. Now the figures would be, meeting would be ending in 10 minutes. You have to restart just now again.
Yeah.
Okay, so
Check your mic. Check your mic. I'm not sure if it pulled out again.
You hearing me now?
Yes.
Right. So I think the formula sheets, if you need to convert Right? As I say, some of us at times have to be able to go between US gallons and imperial gallon. Remember though,
you went silent again. I'm not sure what happened.
Well, it might be an issue. We good?
Yeah.
Yeah. All right. You see, I think I have to twist the computer to work. The fact that I'm left-handed. All right, you hearing me? We good?
Yeah, clearly now.
All right.
Yeah, sorry about the left-handed blues.
No, 1 imperial gallon, remember, is always 1.2 US. The imperial is bigger. Remember that. So if you need to convert, do your conversion. Okay? And Alvin, bear me out. I don't think they confuse you these days. Most of the problems with the exams, they stay with the US gallon, right?
Yeah, they don't go outside of US gallon.
They don't go outside that because
our exam is a US exam.
They're US based, yeah.
Yeah.
And they are, for all intents and purposes, they are the ones that keep it. They call it US customary now. Not they don't refer to imperial. Okay? So that is good. And how much more minutes we have before you cut off?
7 and 7.
Any doubts? Ask me. I want you to get it.
Oh, the decimal point.
Where it is?
No, you have 43.78.
Let me see.
Most of them are saying they're getting 437.85.
You shouldn't. All right. Let me see if it's that. 437?
Yeah,
Let me see.
I think it's off
It could be.
Because
100.
4 by 100 would give you 800 something.
You're right.
By 0.5 would give you one half of that.
Yeah.
So
sorry about that. 525.
Like yeah.
Right. 437, sorry.
0.8.
Yep. Good. You people sharp. You're on your way to passing this thing, you know.
Yeah.
We'll be proud. Yeah. Keep it up. So 407.8 pounds of chlorine you need to deal with that 500,000. And it makes sense too. You know, and we have to start living this thing. You can't have a half a million gallon tank and you're just applying 4 pounds of chlorine. you definitely need a lot more chlorine to do 500,000 gallon tank at 100 milligrams a liter. 437.8 pounds makes sense. Yeah? Okay. Good. So let me clean up. One thing I know when we restart, we lose the whiteboard. All right? How much more minutes? But I could call it some cleaning up.
When you have 2 minutes, I will let you know.
Yes.
Are you using Wi-Fi?
Yes.
I would suggest, because we're having some issues with your audio, it sounds like it's an internet issue. I would suggest that you turn off your video.
Yeah,
your video.
Okay. No problem.
So your bandwidth will only have to do with the audio.
Yeah. And it says to me that you're surely right. Sometimes I'm getting a recording here saying that the Wi-Fi is fluctuating. The provider having some problems.
Yeah. The other thing you can possibly do is go closer to your Wi-Fi router.
Well, it's right in front of me.
Oh, it's in front of you. Oh, okay.
Well, when I say so, maybe I pull out. Yeah, it's better now?
Yeah, it's good now.
All right. Okay, let's take the other problem. And if he wants to restart, he restart, but let's take it down. Again, you have your pen and pencil. It says If a flow of 700,000 gallons, repeat, if a flow of 700,000 gallons per day exists and a uniform chlorine dose of 1.2 milligrams per liter is applied, comma, how many pounds of chlorine gas will be used in 1 day? All right, so let's take it again. If a flow of 700,000 gallons per day exists and a uniform chlorine dose of 1.2 milligrams per liter is applied, how many pounds of chlorine gas will be used in 1 day? How much time for restart there, Melvin? Alvin? Alvin?
Yeah, I'm there.
How are we doing for time for restart?
We have 2:19, 2 minutes, 19 seconds.
Okay. Let's clean up the board a bit. So in the 2 minutes, we could talk about your internet connection is unstable. Just seeing that again. So it's an issue with the provider. So the known and OW. And the unknown two pieces of data. We know the flow. The flow is 700, and that is flow rate. That is Q, whatever you want to call it. We introduced that the last time. Flow. I call it Q when we work the other problems, whatever you want to use. That is equal to 700,000 gallons per day. How much million gallons per day is that? If you divide by a million, it's 0.7 mgd. Okay, and we also know that the dosage, and it's a uniform chlorine dosage,